All right, let's wrap up our discussion of our method of undetermined coefficients with non-homogeneous linear differential equations of higher order with constant coefficients. So let's look at number 13 from the book, and it is y double prime plus 4y equals 3 sine of 2x. So my auxiliary equation will be m squared plus 4 equals 0, meaning m squared equals -4. M equals plus or minus 2i, giving me a yc of c1 cosine of 2x plus c2 sine of 2x, because I see sine of 2x in my yc already. I'm going to have to choose a yp that is going to be a x times what I would think that I would need here. So my yp is going to be a x cosine of 2x plus bx sine of 2x. I think you see why I made the screen wider here. I'm going to actually pull this down here. Just this here. Go. And this is right p. So my yp prime is going to be a cosine of 2x minus 2ax sine of 2x plus b sine of 2x plus 2bx cosine of 2x. Let's put that together. We get our cosine 2x pieces are a plus 2bx cosine of 2x plus b minus 2ax sine of 2x. So my yp double prime is going to be equal to 2b cosine of 2x plus a negative 2a minus 4bx sine of 2x minus 2a sine of 2x plus 2b minus 4ax cosine of 2x. Let's put that together. Yp double prime is equal to, let's put my cosine pieces together first, 4b minus 4ax cosine of 2x plus, now let's put my sine pieces together, negative 4a minus 4bx sine 2x. So I'm looking for yp double prime plus 4yp. So let me just do 4yp here is x cosine of 2x plus bx sine 2x is equal to 4ax cosine 2x plus 4bx sine 2x. So when I add 4yp to this, I'm adding 4ax cosine of 2x, and I'm adding 4bx sine of 2x, zeroing those pieces out. Let me go ahead and scroll here. So that leaves me with yp double prime plus 4yp is equal to 4b cosine of 2x minus 4a sine of 2x. And that needs to be equal to my right-hand side, which was equal to 3 sine of 2x. Okay, so I don't have any cosine 2x terms on the right-hand side, so 4b is equal to 0, and negative 4a is equal to 3, meaning b is 0 and a is negative 3/4, giving me a yp of 0 x cosine of 2x, 0. B is negative 3/4 x sine of 2x. So my y, which is equal to yc plus yp, is equal to c1 cosine of 2x plus c2 sine of 2x minus 3/4 x sine 2x. Sorry, this is a, so this is my cosine term, cosine 2x. There we go. All right. Now, number 15. Y double prime plus y is equal to 2x sine of x. And that means that m squared plus 1 equals 0 is my auxiliary equation. M squared equals negative 1, m equals plus or minus I. So my yc is going to be c1 cosine x plus c2 sine x. I'm going to do some work over here off to the side. I'm going to tell you that this work is just going to be to prove that our first choice that we would think for yp is not going to work. So we're going to think ax cosine x plus bx sine x. Our yp prime would be a cosine x minus ax sine x plus b sine x plus bx cosine x is a plus bx cosine x plus negative a, let's try b minus ax sine x, like that. Yp double prime is equal to b cosine x plus a negative a minus bx sine x minus a sine x plus b minus ax cosine x. So yp double prime is equal to 2b minus ax cosine of x plus a negative 2a minus bx sine of x equals to nothing yet, but I'm going to try to stick it into the equation of yp double prime plus yp prime, and make that equal to 2x sine of x. So when I add these parts together, I get my 2b minus ax, and then I'm going to have a plus ax cosine of x plus b minus negative 2a minus bx plus bx sine of x, and that needs to be equal to 2x sine of x. So my parts with my x cosine of x and my x sine of x drop out, only leaving me with the constant part in front of the cosine and the constant part in front of the sine, and that doesn't work because I have an x sine of x on the right-hand side that I need to compare coefficients for. The coefficient on the left-hand side is 0. I can't, I don't have any left, so this is impossible. So it was the wrong choice for my yp. So instead, we're going to choose yp equal to ax squared plus bx cosine of x plus cx squared plus dx sine of x. And once we make that choice, this is going to work for us. So let's go ahead and find yp prime and yp double prime. Yp prime is equal to 2ax plus b cosine of x plus a negative ax squared minus bx sine of x plus 2cx plus d sine of x plus cx squared plus dx cosine of x. So yp prime is equal to cx squared plus 2ax plus dx plus b cosine of x plus a negative ax squared minus bx plus 2cx plus d sine of x. Okay, so my yp double prime is equal to 2cx plus 2a plus d cosine of x plus the opposite of this is negative cx squared minus 2ax minus dx minus b sine of x plus derivative of this is negative 2ax minus b plus 2c sine of x plus, and then negative ax squared minus bx plus 2cx plus d cosine of x. So now let's combine like terms. E double prime is going to be negative a x squared minus b x plus 2cx plus another 2cx is plus 4cx plus 2a plus 2d cosine of x plus negative cx squared and then minus 4ax minus dx minus 2b plus 2c sine of x. So now we're going to have yp double prime plus yp prime with our new yp that we've chosen. It's going to be a negative ax squared minus bx plus 4cx plus 2a plus 2d. Our cosine piece was ax squared plus bx, so plus ax squared cosine of x plus, this is negative cx squared minus 4ax minus dx minus 2b plus 2c, and our original was a positive cx squared plus dx sine x, and that needs to be equal to, on the right hand side was 2x sine x. So negative ax squared and positive ax squared will drop out. Negative bx and positive bx will drop out. So my yp double prime plus yp prime is equal to 4cx cosine of x plus 2a plus 2d cosine of x. Negative cx squared and positive cx squared drop out. Negative dx and positive dx drop out, leaving me with minus 4a x sine of x plus a negative 2b plus 2c sine of x is equal to 2x sine x. Setting up our system of equations here, we have no x cosine x's on the right hand side, so 4c is equal to 0, making c 0. We have no sine x's over here on the right hand side, so negative 2b plus 2c is also equal to 0, with c equal to 0, that's negative 2b equals 0, so b equals 0. We have no cosine x's, so, but I don't have a or d yet, so let's go ahead and come back to that. So negative 4a is equal to 2, and a is equal to negative 1/2. So 2 times negative 1/2 plus 2d is equal to 0. Negative 1 plus 2d equals 0. 2d equals 1, and d equals 1/2. So my yp, it was ax squared, so that's a negative 1/2 x squared cosine of x. There was a plus 0 bx, so no x cosine x terms. A 0 cx squared, so no x squared sine x terms, and there was a positive 1/2 x sine x. So my y, which is my yc plus my yp, is equal to c1 cosine of x plus c2 sine of x minus 1/2 x squared cosine of x plus 1/2 x sine x. And I'm just going to leave any additional examples that you want to do for yourself from that section for you to do. I think that kind of gives you an idea. I haven't talked much about the superposition principle, but if you see two different things on the right-hand side that are added together, just choose a yp that has both of them in there. I think I did an example with that had a constant plus an exponential or something like that earlier, and that was the superposition principle we were talking about. So I'll come back next time and I'll do some examples with the annihilator approach, and hopefully you like that because there's no guessing what your YP is. There's maybe a little bit more work up front for you to figure that out. You would only really want to use that in a case like this, where you don't want to try something wrong, but where you're pretty confident that you're going to get it right on your first guess. You might just want to use this comparing coefficients, this undetermined coefficients method. So that's it. Again, only use this method or the next method when you have sums, differences, and products of polynomials, exponentials, and sine and cosine. Don't use it for any other trig functions, any other types of functions, elementary or non-elementary. We use other methods for those moving on in the chapter. All right, that's it. See you for the next video.